What's going on, everybody? Thanks for tuning back in. Okay, so before, some of the first videos that I had made was a series on how to construct an asteroid field, and then it slowly merged into an asteroid belt, and a lot of the math that I was doing was a little bit complicated, so what I've decided to do, I've decided to get rid of those videos and just make two very easy videos for you. One to make an asteroid belt around an object, and the other one just to spawn a simple asteroid field. Everything's going to be simplified as much as I can make it, so let's get right into it. So let's open up a project. We're going to start with the asteroid belt. So we're going to need a few things. Very first thing I like to do is save the scene, so let's just call this asteroid scene. Okay, let's actually get rid of 2D. I don't know why that's on there. Let's exit Steam because I don't want to be bothered by that right now. Okay, so let's do a few things. Let's create a couple C# scripts. First one, we're going to call this one our belt spawner. Cool. And then we're going to make one more script, and this is for the actual asteroid itself. And let's call this one, I don't know, belt object. Pretty simple. Okay, so let's create a game object here. We're just going to create a cube. That's a lie. Let's create a sphere. And we're going to zoom in on it here. Let's reset the transform, sorry. And let's make the scale 10, just to give us a little volume here. So let's save the scene. This is going to be what our asteroid belt is orbiting around. Cool. So let's double click on our belt spawner. And this is where we're going to code the actual instantiation of an asteroid belt. So we're going to need a few property settings here. Let me just zoom in so I can give you a better look at the code here. Hopefully that's big enough for you. Okay, so what I like to do whenever I create a new class in Unity is just to get rid of all the stuff it gives you automatically. First thing I want to do is make a little header here, and we're going to call this our spawner settings. And I'm just going to copy this header twice, and actually just one time, and I'm going to call this our asteroid settings. So all the settings under the first heading here is going to be for our actual spawning of the belt, and the asteroid settings are going to be anything we could pass to the actual asteroids themselves. So when I say asteroid in this example, I'm just going to be using a cube. We're just going to pretend that they're asteroids because we're cool like that. So the very first thing we're going to need is a public game object, and we're going to call this our asteroid prefab. Actually, let's just keep it simple. Let's just call it our cube prefab. No need to get fancy. Let's do another thing here. We're going to have a public int cube density. And what I mean by this is how many objects I actually want to be rotating around in the asteroid belt, in the cube belt. Before, what this variable meant in one of my old videos was the actual density times a certain constant, because I was only able to spawn the outer circumference of a circle in one quadrant, and then I had to duplicate it I had to basically multiply it by 4 to get it on all sides and space the asteroid belt evenly. So I found a couple simpler equations. I'm not the greatest with math, but you'll understand how these work. Next thing we're going to do is we're going to have an integer, that's the seed. As I explained before, what a seed does basically is if you input this into the random range generator of Unity, you can basically ensure that even though it spawns all our values randomly, the random sequence it spawns in will be the same. So anytime I stop the scene and play the scene, it'll be the exact same. Okay, so now let's, we need a few more things. Let's get our inner radius. We're going to get our outer radius as well. So this is basically the range of the actual belt. And since our belt is a circular shape, not a sphere, we can define the height instead of having like a random height. Okay, so for the asteroid properties now, we're going to need a few things. First thing I want is our minimum orbit speed. So maybe some of these objects are moving faster than the others. You could just use one speed for now if you want, but I like to do this now just so you can see how everything works. Let's call that our max orbit speed. The next thing we're going to do is we're going to add a rotation speed here as well. Whoops. And in case you haven't guessed, we are going to have a max rotation speed as well. And one more thing we can put, actually no, I'm going to put it up here. it is a bool saying that we are rotating clockwise. Basically, all this is going to control is the actual direction of the asteroid belt, or the cube belt. So, there's a few more variables that we need. These are all going to be private variables. We won't actually have to edit any of them. I could use these, just keep declaring these variables if I wanted to in the for loop that I'm going to create, but I just want to declare them up here so you can see what I'm doing. So we're going to need 3 vector 3s, and my goodness, I can't spell today. So we want our local position, we want our world offset, and we want our world position. So what I'm doing with this is, if I'm going to spawn an asteroid through code, if I'm using specific vectors and whatnot, I have to make sure that these vectors are in relation to the object that this belt spawner is on. Otherwise, they're going to spawn at the actual coordinates I give them, and it won't be anywhere near our object. It will if our object's at the origin, but if our object is not at the origin, then we have to make sure that we move it to that location. A couple more things we're going to need is our public float random radius. This is where we're going to actually declare the radius. We're going to call this our random radian. And then, last but not least, our 3 our 3 coordinates. Okay, so I have a little something I'm going to copy pasta here. If you want to get the random point on the circumference of a circle given by the angle, you would use one of these equations. So this is how you get the x, this is how you get the y. These c's refer to, this x and y and the c right here refers to the actual origin. But since Unity, when we're changing our positions using our local position, our offset, and all this stuff up here, we don't actually need these variables. They can always be set to 0. So the only actual part of the equation we need is these two. If you want to look up more how this works, I'm not the greatest with calculus, but I'm sure you can Google it and figure it out. But these are the equations we're going to use, and it'll give us a much more uniform belt than we were getting previously. Because the problems that we were having before was basically we were only spawning these cubes on a semicircle, a quarter of a circle, I should say, and they would be mostly distributed towards the middle arc of that circle, so even the ends were a little bare. So this right here, if we just basically give a random angle between 0 and 360, or since in this case we're using radians, I believe it's between 0 and pi over 2 or 2 pi, I can't quite remember. I'll look it up if I have to. I'm pretty sure it's 2 pi. And since we're doing it this way, it'll spawn the actual cube anywhere within that 360-degree arc. So now we can make our start function. So first thing we're going to do is we're going to use Unity's random class. And what we're going to do is we're going to call its init state function. And if you don't know what this does, basically I'm passing it the seed that I want it to use for now. And it will forever use this seed that we give it until I change it inside the code somewhere, or if I change it inside the editor itself. This is very, very useful, as I said before. If you're, for example, spawning this in multiplayer, and you want everybody's client to spawn the exact same belt without actually passing them the variables, all they really need is the seed, and then the client can handle everything themselves. So let's make a for loop. If you type for and hit double tab in Visual Studio, it'll auto-complete the for loop for you. So we're just going to make this cube density. Okay, so very first thing I want to do is I'm going to make a do while loop. And basically what this is a while loop that will automatically go through the loop at least one time. And the reason I'm making a loop right here when I'm finding our x and y values, or in Unity's case, x and z, y is going to be the height in our case. What I have to do here is I have to do a little check here, where I have to check if the float is an actual number. The reason I have to do this check, I'll type the function first and then I'll explain it after. So we're going to do z and float dot is an x. The reason I have to do this is sometimes I get a value that Unity can't understand, and the float has too many decimal places, or I'm not exactly sure what happens, but this is how you get around it. So basically, if the x and z coordinates that we get using our using our random, using our seed, using our equations right here. If they don't work, basically just keep going through the while loop till I get numbers that are acceptable by the Unity engine. So very first thing we're going to do is we're going to set our random radius. So through every single cube, we're going to pick a radius between our minimum and maximum radius. So in order to do this, we do a random.range. And if you haven't guessed it, we're going to use inner radius and outer radius. Super simple. Next, we need our random radian. This is going to give us the actual radian value that our two equations above will give us a unique position around the object we are spawning the belt on. So we're going to do the same thing. We're going to do a random range. And it's going to be between 0 and 2 pi, which in Unity we would type as mathf.pi or pi. Mathf, I believe, is a wrapper that the Unity class makes for the actual math library of C#. No problem, we can just use the one that's built in here. So it's going to find us a random radian between 0 and 2 pi, no problem. So the next thing we want to do, we can pretty much determine our y right away. It's basically just going to be between the height that we give it. So let's say we set our height as 10. Basically, we want it to be between 5 and -5. So in order to do that, we're going to do a random range, and we're going to do our height divided by 2, so a negative value of that, and then our height divided by 2. So once again, just to make sure you understand this, basically I'm saying if our height's 10, I want the range to be between -5 and 5. Pretty simple. So now we're going to get our x-coordinate, and how we're going to do that is we're just going to use this part of the equation. That's all we have to do. So we're going to take our random radius that we have selected, and we are going to multiply that by math.f. You can get cosine and sine using the same wrapper, and we're going to do our random radian in here. This is going to be pretty much the same thing for our z-coordinate, except we're going to change this to sine. Not singe, sine. Okay, so this little section right here is going to give us our x, y, and z coordinate, or our vector of where we want our asteroid to spawn. So now the next thing we have to do is we have to translate this cube from the local position to the world position. So our local position is going to be a new vector 3 x, y, z. So now we have the coordinate. Actually, what I should say is from world to local, but you'll see what I'm doing in a second. So the next thing we have to do is we have to get our offset. So basically you just take transform position of our object and you multiply it by this position right here. And that'll give you the offset. So basically where we need to move this to. Oh goodness, what did I do? Sorry, transform, it's our rotation. Sorry about that. Now what we need to do is we need to get our world position, and what we're going to do is we're going to take our position that we are now and add the offset. You get the offset from the rotation, not the position. I apologize. Again, this is something I had to research deeply, but from my understanding, what it does is basically it turns the object the way you need it, gets the distance that you need, and then you just add that to the transform position, and it'll put the cube where it needs to go. Okay, so now that we got that, we need to actually instantiate our asteroid. So how we're going to do this is we are going to make a new game object. We can just call this asteroid. And this could be equal to instantiate, which is static call from game object, I believe. First thing we're going to do is we're going to take our cube prefab. We're going to add our, I believe it's, let me just make sure I got this right. In Visual Studio, you can look through all the different constructors here. I believe this is the one, this guy is the one I'm going to want to use right here. So basically I want to give it a prefab, a position, and a rotation. So the position is going to be that world position we just calculated. Now its starting rotation is a quaternion, and quaternion has this lovely function called Euler, and we could just pass in 3 random degrees from 0 to 360. And if you're wondering where I'm getting those from, hold on, let me just let this calculate. It's going to give me an error. Basically, it's these 3 guys that we're just calculating randomly for each asteroid, or each cube. So let's do our, well, not random range, sorry, it's just range. So 0 to 360. So let's copy that 3 times. And I think I'm missing some brackets here. Okay. So the next thing that we're going to want to do is I'm going to want to take this and I'm going to want to set the parent to the game, I'm pretty sure I can just type transform. Yeah, there we go. So basically what I'm doing is when I spawn this asteroid, whatever object the belt spawner is on, just make that its parent. Super, super simple. Now, the next thing we're going to do is we're going to view our solution explorer here, and we're going to go to our belt object. So again, same thing. I'm just going to get rid of these guys. So what I want to do is I want to create this class, and I want to add it every time we spawn an asteroid. So basically what I'm going to do is I'm going to set up all the variables that we need. Its orbit speed, its parent, which way it's rotating, its actual rotation, and its rotation speed. So let's do that now. Let's do, since we're not actually gonna edit these inside the Unity engine editor, we are just gonna make these all privates, but I will make these serialized fields so you can see them when we select different asteroids. So we're gonna make private game object parent, then we're gonna make our private rotating clockwise. That's going to be the same as it was in the other. We're going to have our vector 3 rotation. Actually, I don't need that because I already set that. And we're going to have our rotation speed. So if you want to look at private variables inside the Unity area, inside the Unity editor, you just need to make them serialized fields. Okay, so let's make a public class, and we're going to call it setup cube or setup asteroid. I know I keep going back and forth, but you know what? Let's call it setup belt object. Make it simple. We'll be ambiguous here. So we're going to pass in the speed. We're going to pass in the rotation speed. We're going to pass in the game object parent. And we're going to pass in the bool rotate clockwise, we'll call it. Okay, so if you haven't guessed what we're going to do here, we're basically just going to take our variables up here and set them equal to the ones we're passing in. So we're going to call this rotation speed. So do the rotation speed. Same thing with the parent. Oh, whoops, I did that backwards. Sorry about that. And then the direction. Okie dokie. All right, so all we have to do now is inside this, we have to create our update function. And basically what this is I'm gonna tell it is, I'm gonna check to see which way we're rotating. If we're rotating a certain direction, whichever way the bool is facing, rotate in that direction. So this is going to be a very simple script. We're going to check if our rotation is clockwise, do one thing. If not, do the other. And the first thing I'm going to do is down here, I'm going to do our transform rotate. And actually, I'll come back to that. Sorry. Okay, let's do a transform, and we're going to call a little function here called rotate around, and we're going to rotate around the parent's transform position. The axis we want to go around is the parent's up direction. So when you get the transform, you get up. It gives you basically a vector pointing straight up in the y. And then you want to do our orbit speed times time dot delta time. Now, if we're rotating the other way, all we're going to do is put a little negative here, and it'll basically rotate it around the axis as if it was upside down, or it's down axis. So it's going to go the other way. Okay. Before I mentioned that I didn't need a random rotation here, actually what I was referring to in my old video was which way the actual cube or asteroid is going to rotate in its spot. So if it's rotating on its own axis. So let's call this rotation direction. And basically in our constructor, we're just going to, or in our setup belt object, we're just going to make a new vector 3. And as we did before, we're going to do a random range, 0 to 360. So give it a random vector in a random direction. And down here, when I actually rotate its own transform, it'll rotate it on that axis. So we're going to do transform dot rotate. We're going to do our rotation direction, and we're going to do our rotation speed again times time dot delta time. Okay, so that's all we need for our belt object here. So if we go back to the belt spawner, what I'm going to do now is I'm going to call it right before I set the parent. And what I'm going to do is I'm going to add a component. I'm not going to stick it on the actual cube prefab. I want to call it from right here. So I'm going to add the belt object to it. And since this is when you're adding a component, it's not returning anything, we can chain it and we could call the setup belt object right after. So we need a speed. So before we set up the speeds, we set up a minimum speed and a maximum orbit speed. So it's going to be basically a random range between our min orbit speed and our max orbit speed. The next thing is going to be a random range for the rotation speed. So it's going to be a random range, our minimum rotation speed, our max rotation speed. Next we have to give it the parent, so that's just this game object right here. And last but not least, we're going to say we're rotating clockwise. Boom. So we're going to set all these variables up inside Unity itself. So let's just double check, make sure we have everything here. Should be good to go. Let's go back to Unity. Okay, so let's go to our sphere. Let's add a little belt spawner to this guy. So now we need a cube prefab. This is really easy to do. Let's just create a cube. The transform is already 0. I'm just gonna drag it down here to make it a prefab and delete it. Save the scene, go to the sphere. So this is gonna be our prefab. All right, so let's say we want 50 cubes. The seed we can leave for 0. You can set that to anything and I'll show you how that works after. So the inner radius, let's set to 25. And the outer radius, let's set to 35. Let's set the height to, I don't know, 5. We're gonna go rotating clockwise for now, so it should spin around this way. If not, then I just set that up backwards and we could just fix that after. So the minimum orbit speed will say 1. The maximum orbit speed is, let's say, 1.5. And the minimum and maximum rotation speed, we could just set to 1 for now. So if I hit play, we should see an asteroid belt spawn around this object. Okay, let's go to the scene here. So as you can see, the radian method that we use this time, the method where I'm not just spawning them in one quadrant, I'm spawning them all around the object, seems to be working, but I think we need a couple more cubes just to see what's going on here. So let's try that again. Let's make the density 200. I just want to make sure that this is uniform. Okay, so you can see we have a pretty even distribution around the object. Okay, so let's do a few more tests. Just going to save the scene one more time. Let's take the sphere. Let's move it away from the origin. And let's give it a random rotation here. So now the belt should still be spinning around the y-axis. So it should be going this way or this way. Oh, whoops. Okay, perfect. So it's staying level with it in relation to the actual sphere. So it still thinks that this is 0, 0, 0 and the transform is perfectly in place. but it is rotating around the position of the actual sphere. So that's good too. Let's just make sure, let's try the switch right here. And okay, so the asteroids are going the other way. That's good. The clockwise and counterclockwise, I guess this is just relative to your camera position, so it doesn't really matter which way we set this. You can change this if it really bothers you, but you'll notice that the switch doesn't work when you have the scene running. That's because the asteroids have that variable cached, and it doesn't actually change when you change it right here. Okay, let's do a few more tests just to make sure everything works properly. Let's zoom out a little bit. Let's make the inner radius 100 and the outer radius 120. Let's change the cube density to 2000. When you're using this many cubes, I'd probably suggest you do an object pooler and maybe have some sort of rendering when you get closer to it. If not, you really don't want 2000 random game objects in your scene. So let's hit play. Let's go to scene. As you can see, everything seems to be distributing nicely around the object in the radius that we've given it. And if we go to the side here, we should see random heights and we should see random spins. Okay, looks like everything seems to be working. So let's go here and let's select this little guy. And we're going to double click him a few times so we stay on him. So as you can see, he's rotating a little bit. You can see they're rotating pretty slowly. Let me just show you that the rotation's working. Let's go back down to 200. Let's make the inner radius 20, and we'll make the outer radius 25. And let's make the rotation speed between 1 and 20. And we'll make this 0.2 just so you can see everything working a lot better here. Let's go to our scene. Let's go to our sphere. So you can see this object's rotating randomly. This guy's moving faster than this guy. All the random variables seem to be working. And we'll do one last test before we end this video. Let's change the maximum orbit speed here to 20, just to see if we can see a massive difference. We'll go to the scene. And as you can see, some objects are going slow, some objects are going fast. Okay guys, so there it is. I took 4 videos that I made before and I condensed them into one for you. So basically with improved mathematics and a little bit of ingenuity, you can make a belt of random asteroids or cubes around an object. And you could use this for other things too. It doesn't necessarily have to be an asteroid. You could make, I don't know, let's say 2 random moons around a planet. You can use this for anything that involves 1 or more objects rotating around a specific object. Okay guys, thank you so much for tuning back in, and the next video is basically going to be how to spawn an even simpler asteroid field. I'll show you how to do it with a few shapes, and that's that. Alright guys, thanks for tuning back in.